So that's why they call it a phenomenon. It's just something that they happen to notice occur. Okay? So even though you've got your occlusal plane, which would say that there's a curvature, Christensen's phenomenon will open up the posterior aspect of that curvature on protrusion faster than the curvature itself. Okay? So in this situation, the patient has to move from here to here to get contact, and then start to translate down the lingual aspects of the incisor. Okay? So there is a form of guidance, but since they have so much horizontal overlap, there's going to be a lot more effect to the posterior teeth. If those teeth were socked right in on top of one another, like these guys, so they're already in contact, any movement forward starts the guidance down the lingual slope. Okay? So there's protrusive guidance, and then there's lateral guidance. Protrusive guidance comes off the central incisors. Lateral guidance tends to come off the canines, ideally. Okay?
So what would steep anterior guidance as a push-out? Would it be that
Steep anterior guidance means that you're going to get immediate disocclusion or disocclusion of the posterior teeth with any movement in an anterior or lateral direction. Yeah, steep anterior guidance means that you get automatic instantaneous disocclusion of posterior teeth in any movement, anterior or lateral. The anterior teeth are set up to protect the posterior teeth. Okay. We'll get into that later, because I'm not supposed to say things in here that I'm not saying for everybody. So, but since it's being videoed and recorded, I'll go ahead and say it. Hopefully I'll remember to say it later. Okay. We call it a mutually protected occlusion. That's where the anterior guidance protects the posterior teeth. Okay. The anterior teeth have more mechanoreceptors, in the periodontal ligament around the teeth. They're also not set up to take vertical loads because of the relationship here. So when you start to put any movement on them, you get an automatic biofeedback that causes the brain to say, hey, we need to open up the jaw. Okay? Posterior teeth with the widespread roots and the occlusal surfaces are made to take vertical loads, so we can load those, well, the theory is up to 10 times more than we can load the anterior teeth. Okay? The forces in the posterior will reach 10 or more times that you'll reach in the incisor area. So as you go back, you're increasing more and more force. So anytime the anterior teeth separate the posterior teeth, it's a mutually protected occlusion. Now there are variations of this. If we go into a lateral movement and all of the force is taken up by the canine, I don't know how many of you guys have canine disclusion, but if you try and take your jaw to the right or left, what tooth is touching? Canine. So that's a canine protected occlusion or canine disclusion. And if you go a little bit lateral protrusive, you may find that it's canine lateral and central. That's considered a group function or anterior group function. Okay? Disclusion. Going straight forward, most of us, we have enough overlap. It's just going to be lower centrals, upper centrals. So that's straight anterior guidance.
So
Mutually protected occlusion, by definition, is the anterior teeth separate the posterior teeth on any movement, laterally or anteriorly. Different teeth will touch in different movements, and different teeth will touch with different patients. Now, some patients work themselves into what we call an anterior-posterior group function occlusion or disclusion. So as teeth wear off, more and more teeth will come into function to help protect things. And if you've worn everything off so that when you move the jaw side to side, everything contacts, that's called a balanced occlusion. So you have contacts on both sides of the mouth simultaneously when you slide in any direction. Balanced occlusions are not protective of anything.
That's not considered a group function.
It is considered a group functionality, a total group functionality. It's very good in dentures, which you'll learn about in the future, but not very good for natural teeth. Though it is an adaptation that some people can live with. Okay?
Why is that good for one teeth?
Because the posterior teeth are going to get wiggled around. So the problem with the balanced occlusion is more in the posterior teeth. If you've got a strong periodontal apparatus, which is going to hold the tooth firmly in the bone, the problem is that there's going to be a weak link that's going to wear out. And usually it's the teeth. It's either the teeth or the muscles. Sometimes. If you've got enough neural feedback, you can cause the muscles to give up. But then what you're going to do is you're going to translate over and probably cause problems on the other side of the arch. The normal tendency is muscles always win. So usually what will happen is the muscles will work on the teeth and wear them out. Okay? If the teeth don't want to wear and the muscles want to win, you'll fracture the teeth. Okay? And I have seen them fractured straight down the central groove all the way to the apex. Had a patient that lived with a tooth like that for several years. Several years. He would bite down and the tooth would go. No sensitivity. So when we took the tooth out, there was a lot of lunch. That tooth was chewing on its own. Okay. So remember, if we don't have the anterior contact, there's a lot of forces which are going to cause the teeth to move around. In a situation like this, it could tend to allow the anterior teeth to erupt, super erupt, which is then going to give us a very steep anterior guidance. Cause a lot of problems for restoring the teeth. Oftentimes you'll get these teeth that will impinge on the roof of the mouth. That'll be their opposition. And then you could even get them so that they start stripping the tissues off the linguals of the maxillary anterior teeth. So remember, if we don't have the anterior guidance, posterior teeth are going to take the brunt of the forces. So there is a reason to have that. If we build in a vertical interference or a tooth that's too high, remember we have vertical dimension, which is established by the contracted length of the muscles. So the muscles are going to want to contract down to that same length. If you put something in there that's high, they're going to push on the tooth. So they're either going to try and intrude it into the bone, impinge on the ligament, or crack the tooth.